Okay, reviewing quadrilaterals. We will be having our chapter test, and today we're just doing review, but we're also doing review again the next day, and the test will be following that. So for this class at this time, it would be Tuesday. Ducks is a pentagon. Do you have a pass? Okay. All right. So what are you going to do with ducks? It's a pentagon. You got to find out what the sum of the angles is. So you should know that formula by heart by now. Pentagon has 5 sides, so we're going to do 180 times 5 minus 2. That's 180 times 3, which would be 540. You guys should have known what to do already, how to solve this. All right, then you're going to take 540 and start subtracting out the angles that are given. 370, that's 460. Total I subtracted, and that gives me an angle of 80, right? You guys got 80? Hola? All right, if angle 1's 80, what's angle 2? Quickly. 100, because they are a linear pair there. All right, Harlem is a hexagon. Hexagon has 6 sides. So we're going to do 180 times 6 minus 2, which would be 180 times 4. Those angles add up to, what's the total? 720 degrees. All right, start subtracting. 490, 590. I just added up the ones inside, subtracted from 720. Are you guys getting 130? Okay. So that's angle 2, guys, 130. Now, these are designed that you don't really have to have a calculator to do some of these, because 130 being that angle measure would make this really easy. What's 180 minus 130? This one's 50. Okay. How many of you are already ahead of me? Just curious. Okay. Let's check it. Toad is a quadrilateral, 4-sided figure. By now, you should know that the angles add up to 360 on a quadrilateral, because we've done them so many times. If you've forgotten, 180 times 4 minus 2 gives you 360. All right, get rid of those. That's 100 plus 85. Subtract 185. Okay, I don't know what that is, but it's 100 and something. Please. What's the size of that? 1. Did I do that wrong? No. It's 285. Excuse me, not 185. Oh, brother. Okay, what is the answer? 60 plus 50. No. 285 is what I should subtract. So it should be 75 degrees. Yes? Okay. Then the angle adjacent to it is still forming a linear pair. Would be 180 minus 75, so that's 105. Pony is a parallelogram. Need to think about your properties of a parallelogram. Opposite angles are congruent. So angle 3, boom, we get 67 degrees. If you got parallel lines, then corresponding angles are congruent. I can get angle 2 is, see, that one's 67, angle 2 is 67, alternate interiors or corresponding. I don't really care which ones you find first, but you should know that angle 1 and 67 are supplements. So 180 minus 67. All right. However you want to look at it, it's going to be 180 minus 67, which is 113. And if angle 1's 113, angle 4 is 2. Because opposite angles are congruent in a parallelogram. Okay. Again, at least we're kind of not doing a bunch of algebra, just thinking about the properties to find the angles. Days is an isosceles trapezoid. You should know some things about an isosceles trapezoid. Isosceles trapezoid have base angles that are congruent. So this angle up here is equal to this angle here. You also should know that this angle equals this angle on the other side. Base angles are congruent. All right, so think about how we might find the angle measures. You got a couple of things going on here. We could find the angle measure for angle 1 by using the triangle angle sum theorem right there. Okay, what's angle 1? 35? Okay, thank you. Now, angle 2. That's a diagonal drawn in there, which cuts this figure. It's like a transversal. It goes through these parallel sides. So 30 can be put up here by the 2 because alternate interior angles are congruent. So we've so far got angle 1's 35. We've got angle 2 is 30. Now tell me what, let's see, how am I going to get angle 3? This one's 115. This is equal to that angle. So I could go 115 minus 30. The angle 3 is 85. Okay. Oh, my pen's stuck. All right, now how can I get angle 4? Well, we got a couple of ways. Angle 4 is congruent to angle DAY. Okay, so that whole corner over there, we could add 30 and 35, and we'll know angle 4. 65. What other angle is 65? Alternate interior angles are congruent. So angle 6 would be 65. And then we can find angle 5 because angle 4 and 5 are a linear pair. So 180 minus 65, well, it should be 115. Bunch of reasons, actually. Consecutive angles are supplementary, so 5 and 6 add up to 180. Okay, whoa, what a great name for a kite. Wind. Kind of need some wind to fly one. Right. All right, so this is kite wind, and you got a 40-degree angle. Now, what else do we know about a kite that would help us solve for all these angles? These cross at a what? Right angle. Okay. The diagonals, we need to know our terminology, though. The diagonals are perpendicular. It's in the back wall. All right, so we have right triangles. All 4 of these are right triangles. 2 sets of them are congruent. So since there's a 40-degree angle here, let's find angle 1. Quickly. 50. Well, how do you do that quickly? Well, if you have a right triangle, 180 minus 90 is 90. 90 plus 90, these 2 angles add up to 90 all the time. So a 90 minus 40 would be 50. So angle 1 is 50 degrees. What now can I do with that? Well, I got some angles that match these. This triangle is congruent to that triangle. So what's angle 6? Yep. What's angle 5? 50. Okay. All right, now I'll go ahead and try to get these other angles. I've got a triangle over here. There's some congruent triangles also. This long skinny one is a right triangle. These 2 triangles are congruent to one another. Okay, so those numbers are going to match up. So first let's find angle 2 by triangle angle sum theorem. 180 minus 90, or which is 90. 90 minus 32, that's going to give me angle 2. So that's 58. Okay. And if that's 58, so is angle 4. Oh, what's angle 3? Got to match this one because see that long diagonal? It bisects the opposite angles. Okay, so that should have been 32. Okay, 32 and the other 2 are 58. Okay, 7 is slow, and it's a trapezoid. Starting with the 70, find angle 1. Quickly, should be doing that one in our head. 110. Where's another 110? Stay on the side with the same transversal, guys. So what angle could also be 110? Angle 3 or 2? It's got to be 2. Okay, alternate interior angles are congruent, so angle 3 is 70. And those two form a linear pair. So we got 110 for angle 2 and 70 for angle 3. Now, the angles 4 and 5 are not related to these angles. Okay? They're going to be, you're going to use the 78 to get them. So what's angle 5? 78, because alternate interior angles are congruent. And then you can find angle 4 by 180 minus 78, linear pair. That'd be 102. Okay. Who's still ahead of me? Anyone? Okay. Bugs is a rhombus and gum is equilateral. Triangle gum. Start with triangle gum. What are the angle measures in an equilateral triangle? All of them are 60. Okay. So I got angle 1 and 2. Now let's find angle 3 because 1 and 3 are a linear pair. So that would be 120. I'll put it on my picture. I can figure out angle 6 because of this 120. Opposite angles in a rhombus are congruent. So that's got to be 120. And the rest of those angles are congruent to one another. And that's because you've got isosceles triangles. Well, and the diagonals of a rhombus bisect opposite angles. So these are all the same size. How big are they? How you get 30? Because what? Yes. So, all right, 180 minus 120. The sum of the three angles is 180. 180 minus 120 is 60. 60 divided by 2 is 30. So all of these guys are 30. Any of these pictures could be on your chapter test. All right, number 9. We've got a regular, these are regular pentagons. That means all the angles are the same size. I'm not going to mark all of those, but these are all equal, okay? All right, so let's figure out the size of the angles inside of a pentagon. You may already know it because we've done it quite a few times, but pentagons have five sides. So we do 180 times the number of sides minus 2, which is 180 times 3, and that's 540. All right, now, there are 5 angles of equal measure. So we take and divide 540 by 5 and get 108 degrees. Okay, so if that's 108, how big are 2 and 3? The whole thing's 108. They'd be half of that because that thing is a line of symmetry. So it cut that angle in half. So 108 divided by 2 gives me angle 2 is 54 and angle 3 is 54. Anything else 54? You see how, yeah, these are similar figures. The angle measures are the same in similar figures. So angle 2 and 6 are congruent. They're corresponding as well. So that's 54 degrees. Now 4 and 5 can't possibly be 54. What are they? How are you getting 126? Well, 180, these are 54. 180 minus 54. Okay, those are a linear pair. Okay, so that's 126 for angles 4 and 5. 10 says, suppose you asked to draw, you got asked to draw a 36 gun. I hope nobody asks me to do that, but that'd be quite a bit of, be hard. Anyway, How big would this, what would the sum of the interior angles equal? Well, that's that formula, 180 times the number of sides minus 2. This is going to be a pretty darn big number because we're going to do 180 times 34, 6,120 degrees. And I only knew that because I did it twice already. All right, find which each of the angles would be how much? Well, we need to take 6,120, and divide it by 36. 170. Guys, you should be calculating. You will be less bored and have much more, you'll remember things better if you do the calculating. All right, it says write an equation and solve for x by showing all work, then find the measures of the indicated angles. All right. Our next problem is Rhino, the parallelogram. What do we know about these angles? Say it louder. They are supplementary. Yes, they are not equal. Just a shout out to anyone who thought they were equal. They are not equal. Okay, opposite angles are equal. Consecutives are supplementary. So I'm going to add up my x's right away. 4x and 11x. I got 15x. I got a 14 and a 1. I'm going to put them together, get 15. And that equals 180. They're supplementary angles. So you guys do your algebra. Subtract your 15 from both sides. And divide by 15. Pen stuck. There we go. Okay, 165 divided by 15 is 11, isn't it? It says to find the measure of angle R. Well, where do you need to plug in if you want to know R? You're going to plug in for X on the N angle or the I? N. Okay, got to plug it in here because these angles are congruent. So you're going to do 11 times 11 plus 1. It's 121 plus 1, so you should be getting angle R is congruent to angle M, which is both of them are 122. Angle O and I are congruent, so I'm going to plug in for I. 4 times 11 plus 14. It's 44 plus 14, which is 58. Both of those are 58. And you actually could have gotten them by doing 180 minus 122. Number 12 is sand the quadrilateral. Oh my gosh, I already talked about this. How much do the angles add up to? Quickly, hopefully you remember. 360. Add your x terms. I got 9, 10, 11x. I've got 100 minus 5, which is 95, plus 1, 96. And they total 360, all four angles. So I subtract 96 from both sides. And that's, what's that, 2? 254. Okay. Then divide by 11. Can someone tell me what 254 divided by 11 is? It's 2. Oh, no, it's 250. Oh, it's 264, isn't it? I thought somebody said 254. My problem. All right, so 264 divided by 11 is, I don't know, 20 what? Okay, 24. Measure of angle A, we're going to plug in 4 times 24. That's going to be 96. Measure of angle D, we'll do 2 times 24 plus 1. You guys can finish that off. Plug them in. Leave it to George to name the pentagon Leroy. Leroy, the pentagon. All right, equation. First, we got to figure out how much the angles add up to in a pentagon, which we might already remember because we did it once today already. 540. Okay, so let's add up my x's. 2 plus 4, 6x, 7x, 8x, 9x, 10x, 11x, 12x, and then another 4 would be 16x. Add up my numbers. I've got 12 and 14 and 2, and they're all positive, so 10, 26, 27, 28. The total is 540. Okay. Solve and plug back in. And what is 512 divided by 16? 32, okay. And then you will just substitute back in for each angle that you're asked to find. $96 plus 14, 100, 110 for L. And then just finish off those other two angles. Can someone tell me how to set up or what I should write for an equation for the rhombus? And it's not the last problem. Set them equal, Chloe said. Yes. All right, so 10x minus 11. This is because opposite angles in a rhombus are congruent, or in a parallelogram for that matter. So 10x minus 11 equals 7x plus 7. Get your x's on one side by subtracting 7x. You'll have 3 times x minus 11 equals 7. Add 11 to both sides and divide by 3. Should have gotten 6 for your x value. And then it wants you to find the measure of all the angles. So I'm going to pop in 6. 10 times 6 minus 11 is 49. Now, if angle A is 49, angle T is 49, but it didn't really matter. We need to find the other two. So they're not 49. They're 180 minus 49 each. So it's 131, right? For angle L and angle S. I hope this is kind of just driving home the properties so that you'll be ready to, if they have an algebra equation on them, you're just going to do the same. Or if there's numbers. Okay, we got gopher the hexagon. Okay, so our gopher adds up, the angles all add up to 180 times 6 minus 2, which is 180 times 4, and that's 720. Yep. I've got 1, 2, 3, 4, 5, 6x. I've got 20 plus 5 plus 5, which is 30, equals 720. Okay, go ahead and solve for that and find those missing angles. Is that right? 115 for x? Angle O would be 115 plus 20, so it'd be 135. Angle P is x, so 115. And angle R, 115 plus 5, 120. Okay. N is parallel to M. That means we have to apply our properties of parallel lines. So those angles are not congruent, but supplementary. Okay, they add up to 180. So 15x equals 180. 2's canceled out. All right. When I divide by 15, I'm going to get 12. I'm going to substitute back in 12. So that's 120 minus 2, so that's going to be 118. For angle 2, because it's vertical with that one, plug back in if you like down here. 5 times 12 plus 2 would be 62. And that would be the same for angle 1. Okay, so because those are corresponding. So where else do I put, let's see, I need angle 3. It's going to be 62. And then 4 and 3 are supplementary, or you could say angle 2 and 4 are corresponding. So angle 4 should be 118. And angle 5 is vertical to it, so 118. Okay, what do I do? Okay, we did triangles with ratio of the angles 2 to 3 to 4, something like that before. What you did was put an x on these. Okay, so it's going to be 2x plus 3x plus 3x plus 3x plus 4x. Oh my goodness, get myself tired. You got a pentagon. What do those angles add up to by now? Oh, did I? Oh, I did it, yeah. 540, right? I mean, we've already done that. How many times? 180 times 5 minus 2. It's 540. I'm going to add those up now. Wait, that's 9, 10, 11, 15x. All right, divide by 15. Set x is 36. Okay. Now, to find the measures of the angles, they correspond to the letters and the order that they wrote the ratio. So angle A would be 2 times 36, which is 72 degrees. Angle B would be next, and angle C and angle D are all going to be the same. So we're going to do 3 times 36. It's 108. And then angle E is 4 times 36. 120 plus 144. I guess I should be writing the measure, but anyway, the measure of angle A, the measure of angle B, the measure of angle C, the measure of angle D, and the measure of angle E. All set? Okay, am I going too fast for anybody? Nope. Okay, suppose you were asked to draw a regular decagon. Decagon, how many sides? All right, 10. The sum of the interior angles would be 180 times 10 minus 2, which is 180 times 8. And that's 1,440, right? Then what would each angle equal? Divide by 10, for 144 degrees each. Okay, crossword puzzle. We're going to have a clue that describes a figure in the coordinate plane. All right, let's go to the problems. Boom. 2 across. The vertices are -1, 1. Just draw the little figure, 1, 2, 3, 1, and -1, -1. All right, this thing looks like it might be a, well, I'm going to prove it. We'll check if we got any parallel lines. So it says slopes. So I'm going to go up 1, right 2. That'd be 1/2. The bottom, I'm going to check if it's parallel to that bottom piece. And so I'm going to climb up 2, right 1, 2, 3, 4. 2/4 is the slope of the bottom, which reduces to 1/2. All right, that means we have parallel lines. Okay, so you got two sides that are parallel. Parallel, parallel. Now, the other two, this has a slope of undefined. And this one has a slope of down 1, right 2. Right? Yeah, -1/2. That doesn't really matter what the slopes are there. Those aren't parallel. Okay, their slopes are different. So if I've got one pair of parallel sides, what is this thing? It's a trapezoid. Okay. So you go to the crossword on the back page. Was that 1 across, right? I mean 2. So we're going to fill in trapezoid. All right, next question. We put them in a nice order here. Oh, 5. In order for the figure in 2 across to be isosceles, an isosceles trapezoid, its diagonals would need to be congruent. Need to have been congruent. They're not, but so to the back page, that was 5 down, congruent. I don't know why I'm all of a sudden making all caps, but that's okay. Okay, boom, 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 back again. The next one is number 3 down. Vertices, -3, -2. -1, 1, and 2, -1. This thing is telling us to classify the triangle by its side lengths. So I'm going to first find the distances. So I'm going to count how I have to move to go from this point to this point. That's 3 and this is 2. So let's do it like Pythagorean theorem. One of the distances would be the square root of 2 squared plus 3 squared. That's 4 plus 9, so it would be the square root of 13. Just leave that alone. I'm going to go over here and count how far it is to go to the right. 1, 2, 3, down 2, so that's the same distance. 3 squared plus 2 squared, square root of 13. So that means this thing's isosceles right now, right? So if I want to find the length of this other side, I'll have to count 1, 2, 3, 4, 5, and 1. 5 squared plus 1 squared would be 25 plus 1, which is square root of 26. All right, so it's not equilateral. Okay. Now, I'm going to check. Let's see, what was the question? This would be isosceles, isosceles. And if you were looking at that crossword anyway, it starts with an I, right? ISOSCELES. Okay, sorry for all the paper flipping. I think I'm on 4, and this is, what is the angle classification of the triangle in 3 down? What were the slopes? Up 3, right 2. And what was the slope of the other side if I actually do the slope? I can't count it like this. I'd have to go from here to here, and I'd go down 2, right 3. Down 2, right 3 is -2/3. Check those slopes out. These are opposite and reciprocals. Now, because they're opposite reciprocals, these lines are perpendicular, which means we have a right angle. So it'd be classified as a right triangle. Let's see if that fits. What one was that, right? R-I-G-H-T, those 4 across. Okay. Next one we're doing is 9 across. A quadrilateral has vertices 0, 3, that's up here, 2, 4, 4, negative 5, and 6, negative 4. What is this going to make? Looks like it might be a rectangle. All right, the slopes. Up 1, right 2, 1/2. Check the bottom. Up 1, right 2, 1/2. That means these sides are parallel. Okay. Count the slope from this point to this point. You're going down 8, right 4. Negative 8 over 4, which equals negative 2. The other one is also down 8, right 4. Negative 8 over 4 is negative 2. Okay, check out the numbers. These slopes are opposite and reciprocals, so the lines are perpendicular. That means we have right angles in the corners. What does it mean that's going to be? If it's got 1 right angle, it has 4 right angles. The slopes were congruent, therefore it's parallelogram with 4 right angles. I don't really need these distances. This is a rectangle. I can tell, okay, that these are longer than those, so I'm just going to go for rectangle. Let's see if it fits the puzzle. What was that? I forgot. Was that 9? 9 across. Thank you. Rectangle. All right. Oh, it says the consecutive sides in the figure and 9 across are perpendicular. That's how we determined it was a rectangle. Whoa. Perpendicular. Was that 7 across? I did it right? Okay, perpen. I don't want to mess up. Okay, you've got 4 more. I'm only going to get probably 1 more in here. I'll probably continue after you leave. All right. A parallelogram, negative 3, 4. So good at plotting points. I hope we're fast. 0, 3. Oops, right there. Negative 1, 0, and negative 4, 1. I use my special tool. I'm thinking we might be getting a square, possibly. All right, slope. Down 1, right 3. Negative 1/3. Slope at the bottom. Down 1, right 3. Negative 1/3. Bless you. Slope of this side. Up 3, right 1. 3 over 1. Both of them are 3 over 1. Okay, these are negative reciprocals, so we have perpendicular sides. Okay. Length of the sides. Square root of. You've got 3 and 1. So 3 squared plus 1 squared. Just look at those slopes. They're all going to be 3 squared plus 1 squared, or the square root of 10. Still have them in 1/2. All right, so this thing is a square. All the sides are congruent, and the angles are all right angles. Where was that? 6? What? Oh, is that the bottom 10? SQ. Oh, the one that's all by itself. What a strange crossword. Okay, so 10 across was a square, and now we'll go back again to 1 down. Got a quadrilateral with vertices at 0, 2, 2, 5, 4, 3, and 6, 6. Looks like this one may be a rhombus, but we got to prove it. So we're going to check out the slopes. I got up 1, 2, 3, right 2, 3 halves. Up 1, 2, 3, right 2, 3 halves. Up 1, right 1, 2, 1, 2, 3, 4, 1/4. Up 1, right 4, 1/4. Okay, so opposite sides have the same slope. So that means we've got parallel sides. And this would have to be a parallelogram. So we go to the puzzle. Let's see if that fits. Now I've forgotten. Was that one down, I think? Parallelogram. P-A-R. Para. 2 L's. Uh-oh. Did I put that in the... Oh, I'll have to pause a second. Okay, apparently I forgot what one that was that we got. Parallelogram. Oh, 1 down. Okay, so... Parallel. It's 2 L's. Oops. Oh my goodness. Parallelogram. Sorry for that. All right, parallelogram. Back to number 6 now. A rectangle's vertices are -1, 2. Plot the points. Oh, this one's actually got letters. 4, 2. 4, -2. And -1, -2. Looks like a rectangle. And if you were to find the midpoint of AC and DB, let's see if that's what they're talking about. 1.50. Yep, midpoint. All right, so let's go back. Midpoint. 1, 6 down. And finally, 8 down. Got a quadrilateral with a 0, 1 as a point, -5, 3, -2, 6, and -5, 6. Oh, that's a side of 3. That's a side of 3. This one, I'm thinking, is a kite. So the distances are 3, 3. Down to right 1, 2, 3, 4, 5. That would be 2 squared plus 5 squared. The square root of 4 plus 25 would be 29. Find the length of this side. Down 1, 2, 3, 4, 5, and 2. 5 squared plus 2 squared. It doesn't matter if you do the x's or the y's first. The sides are equal. So this is equal to this. These are equal to one another. Therefore, this is a kite because it has 2 pair of consecutive congruent sides. K-I-T-E. Okay, that's the end of the review of quadrilaterals. George Johnson, or actually it was review polygons. Have a great evening.